In the beginning, the universe was created. This has made a lot of people very angry and been widely regarded as a bad move. Eventually, it has led to this puzzle being created, and the situation has not improved any. This is a walkthrough for solving Mostly Harmless by Aaron H. If you want to tackle the puzzle yourself first, please see the link in the description. As we go through the puzzle, I'll I'll read out rules as we encounter clues. There are a few different clue types, so I feel it best that we sort of review the rules as we encounter them, just to keep them fresh in our mind. That being said, this is a dynamic fog puzzle, so the grid is covered with fog. Entering correct digits may clear fog elsewhere. No guessing is required. Any lines and markings continue and connect beneath the fog, and unless revealed, no additional clues should be assumed to exist under the fog. So what we can see here first are some white circles. These are known as crop key dots. The white variant indicates that the cells are in a consecutive relationships, so they differ by one. So under the fog here, we can see that they're all chained together, so the circles do complete on each side. So what we can sort of safely say about what we can see here is that we know it's the string 1 through 9 in one direction or the other. And if we look at that for a little while, we might realise that in the middle it's always the same digit, which is a 5. And that opens up a further part of the grid. Here's where we encounter the X clue. So between cells here, an X indicates that the two digits sum to 10. So what we can actually start doing with this line, and all the way along it, we know this is either a 1 or a 9, and we know this is either a 1 or a 9, but whether this is a 1 or a 9, in a 10 relationship, this tells also a 1 or a 9. And the same, similar can be said here, so these will be 2 and 8. These ones here will be 3, 4, 7, and then these final ones here will be 4 and 6. So that is all the cells that have a partner that adds to 10 in this box. Only remaining digit left over is a 5. So that opens up a further part of the grid. Here we have a German whisper. So German whisper along a green line, adjacent digits will differ by at least 5. So what this sort of line causes to happen is because there has to be a difference of 5, the digit 5 can't go on the line because there's no Sudoku digit that's sufficiently different to it, either higher or lower. What this then causes is a bit of oscillation where we go from a digit that is below 5 to above 5 and keep cycling, and but you don't know whether this is the high digit or this is the high digit to begin with, but you know that it alternates along the line. When the construction is like this and it's a whole set of Sudoku digits, you can work out that there's a pattern. So the digits along this line must follow this sort of order, either backwards or forwards. So that's why we can mark it up as pairs. So it will be in some order, the digits going 4, 9, 3, 8, 2, 7, 1, 6, or it might start with 6 here and follow the same sort of pattern flowing through the box. But what you may notice is, once again, these are the same sort of pairs that we've been seeing elsewhere. And once again, this digit is a 5. So that opens up a further part of the grid. What we'll cover off first here is the yellow Nabna line. So a yellow line cannot contain two digits anywhere on the line that are consecutive. So it's a bit like a opposite to a white crop key dot here, but it's not just adjacent digits. If this digit was a 1, then none of these digits could be the digit 2. Uh, and similarly, if this was a 4, none of these digits could be a 3 or a 5. Now, because it's a 5-cell lambda line, we know uh, sort of with the digits 1 through 9, the only way to have digits that are at least 2 apart and 5 of them is the odd digits. Yeah, this line will only consist of odd digits. We can actually go a little bit further on this because we actually have 3 and 7 looking at this column. So that means these 2 digits here are from 3 and 7, and then the remainder here will be from 1, 5, and 9. And obviously that can't be a 5. So yeah, that's what we can sort of say about the lambda here. Um, then we can come across and look at this box, and what these are V clues. Similar to the X clues in the same family. However, between a V, the digits will sum to 5 instead of 10. So what we can say about these is these will be the digits 1, 2, 3, and 4 in some arrangement. So if we look at this one in particular at the moment, we can see that there is a 2 and also a 3, 7. So 2 and 3 are both looking at that. So that can only be a 1, 4 pair, which adds to 5, which means the 2, 3 pair will be in this other clue. From this, we've got a lot of pencil mark going on, but what we may notice is these digits here all have to be even in this box because all the odd digits are here. We've got 2 and 8 and 4 looking at this cell, which makes it a 6. And yeah, we can continue this along a little bit because we have a 6 here and a 2, 8 looking at this cell, so that is a 4. And then the remainder here is 2, 8, which is left over. So getting this digit actually causes the German whisper to become resolved. So we can actually now fill this out and causes a bit of a chain to get us some further digits as well. And then continues on up into this box, which exposes a little bit more of the grid up here. I'll just finish off some of this work down the bottom before we move along. Okay, so what we have up here in box 1 are a different type of crop key dot. So these are the black crop key dots, and what these dots indicate is that the digits here are in some sort of doubling relationship. So you can have 1 and 2 doubled, 2 and 4, 3 and 6, or 4 and 8. That's all the possible pairs. And if we examine this box a little bit, we will notice that this is actually a string of 4 digits, which means it must be the, uh, the 1, 2, 4, 8 run in some order, because that's the only way to get 4 consecutive pairings of digits, and we know 1 and 8 must go at 1 in the ends, and the 2 and 4 will be in the middle, which just leaves this over as the 3, 6 pair, which is actually resolved and opens up more of the grid. But just before we move on, we'll finish off some pencil marking here because these digits are 5, 7, and 9. Okay, so what we have encountered here is a modular line, so along a teal line, Any three adjacent digits must include one digit from each of the modulo 3 sets, and those sets are 1, 4, and 7, 2, 5, and 8, and 3, 6, and 9. So modulo arithmetic, when you divide a number by 3, um, you get a remainder, and it groups them together based on that remainder. So if you divide 3, 6, or 9 by 3, you have 0 left over. If you divide 2, 5, and 8 by 3, you have 2 left over. And if you divide 1, 4, and 7 by 3, you have 1 left over. So with this sort of line, always find it helpful to color code it. You know, a run of 3 digits will have one of each sort of set. So once you get that run sort of going somewhere, you could continue it on here because we can see these cells continue on, but for the moment the fog's just exposing this part of the line, so sometimes it's useful to consider the effects. And if we look down the bottom here, there is a 9 and a 3 looking up at this run, which must include one of the sets from the 369 set. So that actually means that the 6 is up here somewhere. This one rules it out of here, so we're left with it being in one of those two cells. This is actually now looking down at this cell, so we know that's actually a 4, which gives us the orientation of this line, so we can actually fully write this in. Okay, and that bounces back into box 1, and if I type things in correctly, I can also mark that up. So, yeah, we've solved what we can see. So at this point, it's often helpful to do a little bit of exploring around of what you can do Sudoku-wise. And if you go on a bit of a hunt, you may eventually come to this cell, which actually sees all of the odd digits and most of the even digits. So the only digit that isn't seen by this cell is a 6. So we can actually punch that one in, and that resolves the 6 back in this box as well. At this point, I'll continue on with our colours. So this run needs a blue, this run needs a red, and let me just continue that along. Okay, so we know this is 3 and 9, and then we've just got to work out what red and green actually match up to. So firstly, it will once again, like some things that we can't particularly deduce, and there is some more Sudoku to do. So if we come and look in this column, we still have the digits 4, 7, and 3 to place. And this 3 here rules it out of this box, making it a 7. That is now definitely a 4, and that is now definitely a 3. So this then comes back into here, and yeah, we've got no 4s there. That can't be a 4, so that's the only place to put a 4, which makes this the 1, 4, 7 set being green. 7 sees this cell, so it's a 1, and that is a 7. So the red set will be the 2, 5, 8 set. So 5's ruled out of both of those cells, so that is a 5. And we've got 2 and 8, so that is the 8 and that is the 2. And at this point here, it's kind of obvious where to move to next, but I'm actually going to move on to just actually filling in the remainder of this grid as much as I can for the next stage. So firstly, that is a 5, and be a 1, that would be 9, no, it's not the 5, it's 2, it's 1, that is 3, 9, 3, that resolves this up here. And actually, what we can kind of see down here, which make it a bit easier, is these digits are roping. So 4, 5, and 6 won't be in those cells. So this would be 4, 5, and 6. 1, 2, and 3 is up here. That's not a 2, so that is. And this would be the 7, 8, and 9. So that's not 7. That's 7. This is a 5, 6 pair looking at this cell, so that's 4. This would be the digits 7, 8, and 9, not currently resolved. Then coming down here, this will be 7, 5, and 9, but can't be a 7. This will be also 7, 5, and 9, which makes that triple in the box. And then this here will be 1, 2, 3, 4, 5, 6, and 8. Okay, and when we, I'll pre-remove the 9 out of here because this is going to be a 9 as well. So gets us to a final stage. We'll punch in this digit and you will notice some of the flog clears here, but it actually doesn't really provide us much new information. It just is sort of indicating that there's something interesting about these cells, and we'll take a closer look at them now. So this here is in a setup which is known as a Y-wing or a bent triple, and it's sort of helpful. Will be we'll highlight them so that they be easier to keep looking at. And this is our sort of target cell that we're going to look at what happens to it. And this cell here is what I'm sort of going to use as a bit of a question. So if I make this one a 7, then that cell obviously becomes an 8. But if I make this a 5, then this cell becomes a 9, and this cell then becomes a 7, which also makes this one an 8. So no matter what choice we make here, this cell can never be 7. So it's sort of ruled out by a little pattern that is able to be recognised. It's a bit more of a traditional plain Sudoku technique that isn't seen a lot in variant puzzles. But we can now punch in that digit, and that then gets the 6 here and the 5 here, and then if we enter the 7 there, that clears the remainder of the fog. And this here is a maximum cell. So cells indicated by the greater than symbols must contain a digit that's greater than all of its neighbours. As the 8's here, this must obviously be a 9, and this is going to resolve the rest of the puzzle for us. And that is the solution walkthrough for Mostly Harmless. I hope you found this informative, and thanks for watching. If you want to make any comments, please do so. Thank you very much.